You guys, welcome to factoring quadratic expressions, and you guys have come a long way because right now you guys are in phase 8, or you must have skipped to phase 8. It does not really matter anymore, but phase 8 is all about, yes, our A value is still, it gets some composite numbers like 25 or 49, something like that. But we're really going to focus on two main structures today, which is perfect squares and differences of squares, and those are going to be how the answers are going to be formatted. This was previously done in phase 3. It was previously introduced in phase 3, but I want to introduce it again because at that point in time the A value was equal to 1, and so maybe the problems were just a little bit tad easier, whatnot. But let's just get down to it. For some of these examples, I'm going to give you guys 6 examples today, and then plus you're going to have 6 you do problems for you guys to do on your own with explanations and quick answers to come afterwards. Let's just get started. So I'm going to do example number 1 first. Alright, we have a trinomial 9x squared plus 24x plus 16, and I'm just going to just take a small shortcut and say, just like in the previous phases, if you have watched them, I want you guys to split the first and last term into factors, and then you're going to create some sort of multiplicative combination that will add up to the middle term. And so that has been the staple format pretty much for all of these phases. Let's go try this one out. I don't think we can take out or factor a GCF. There's no number that we can divide 9, 24, and 16 by. So, well, let me just put this in the middle. Our target goal is 24x. There are a couple ways we can split up 9x squared. Just because it is not prime, we can have 9x times x. We can also have 3x times 3x. So there's going to be that combination as well. Positive 16. What are two numbers multiplied to positive 16? Well, 16 times 1. We even have 8 times 2. And then also 4 times 4. Okay. This is the point in time you're going to do trial and error and try to figure out which combinations are going to help us get the 24x. And so the right combination that will work is you're going to multiply the 3x with the 4, and then this 3x with this other 4 over here, and then when you add them up, it's going to equal to the 24x. Let's just try it out. 3x times 4 plus 3x times 4, which is that one. Okay, let's see if it works out. 12x plus 12x. Yeah, that's the 24x that we want in the middle. Okay. Now we're going to create two factors, two parentheses. Just a small reminder that the first pair goes on the outside. And then the second pair goes on the inside. In this case, though, it didn't really quite matter too much because we're going to have the same factors, 3x plus 4 times 3x plus 4. But just like on phase 3, if you see two of the same parentheses, two of the same factors, you are going to write this as 3x plus 4 quantity squared. And so that's how you're going to factor this one fully on that case. Okay. All right. Well, I'm just going to keep going with the examples. That's example number 1. Let us do example number 2. Your first question always is, can we take out a greatest common factor? Is there a number that we can divide all of these by? 18x squared plus 48x minus 36. Since there's a negative in front of since your A value is negative, we can take out a negative number. The highest number you can divide 16, 48, and 36 by is going to be 4. So we're going to factor out a 4, and I'm going to do my reverse distribution arrows. just so that I remember to put the -4 on the outside. Okay. All right, anyway, let's do the leftovers first. 6 divided by -4 is going to be 4 and then x squared. 48 divided by -4 is going to be -12x. And then -36 divided by -4 is going to be +9. Okay, and then don't forget the -4 that we've extracted. Okay, now it's going to be the same steps throughout this part. We want a -12. I don't think we can take out any more numbers anymore, so we're going to do this method here. 4x squared is going to be 4x and x. I see another possibility of 2x times 2x. Okay. 9, we can go 9 times 1. We can also go 3 times 3. But since we want a -12, maybe we don't want two positive numbers. Maybe instead we want two negative numbers instead. Okay. And so I think the correct combination that we can create a -12 is going to be the 2x with the -3 and this 2x with the other -3, and let's see if that works out. 2x times -3 plus 2x times -3. Okay, so 2x times -3, 2x times -3. Well, that's going to be -6x plus -6x. Is that going to be the -12x that we want? Yes, it is. Okay. So now we can turn this big factor into two mini factors. Again, the first pair that works goes on the outside. I'm just keeping consistent with the methods that has been taught. Okay, even though they're the same numbers, I'm still doing the same methods. Okay, and then some of the students tend to forget the number that we factored out at the very beginning, so just make sure you put that -4 over here. Okay, and they are two of the same factors, and so to round this up, to end this, it's going to be -4 2x minus 3 quantity squared. Okay, after I do example number 3, we're going to be halfway there through the examples, and then you guys can do the you-do problems if you decide to do so. So let's move on to example 3. You know, some students kind of tend to be a little bit scared if there's two variables within x and the y, but the same process is going to be the same where you're going to break it up. Well, let's just do it. 49x squared minus 70xy plus 25y squared. I don't think we can do a GCF on these three. We can't take out an x just because this doesn't have an x. We can't take out a y because this doesn't have a y. Okay, so our goal is a -70xy. 49x squared, we can do, 49 and 1. Sometimes I already think 7x and 7x, okay? Okay, 25y squared, for me, I immediately think 5y and 5y, but because we want a -70xy, maybe -5y times -5y will be better to make that 25y squared, okay? And so the pair that will work is the 7x should go with the negatives. All right, let's try this one out. 7x times -5y plus 7x times -5y. This should work out because they're both going to be -35xy. Okay. Plus a -35xy, and that's going to be the -70xy that we want anyway. Okay, so it does work out, these pairs. Okay. Again, I am just doing this by, I mean, after a while you guys can skip some steps. I'm just showing you guys again the methods, how to put those terms back inside the factors. Okay, first pair goes on the outside, second pair goes on the inside. It's just that in this phase, these factors are going to be the same. Okay, in the last previous phases, they were not the same, and so that's why we needed to do that. Anyway, your final answer is going to be 7x minus 5y, and then quantity squared. All right, we are halfway there, and so let's just move on to example number 4. Okay, 9x squared minus 16. We don't have a middle term, and I showed you guys in phase 3 that there were 2 different ways to do this, but maybe this is the differences of squares. Okay, let's check it out. Well, let's see if we can square root 9x squared. What is that? That's 3x. Okay. Let's square root the 16. Well, that's going to be 4. Okay, 1, 2, and the third thing that we need is there a minus sign? Yes, there's a minus sign in between. Okay, so if you see that this is the differences of squares, then we're going to follow this structure over here, just like in phase 3, and the x and y represents the terms that have already been square rooted. So your final answer is going to be 3x plus 4 and then 3x minus 4. Okay, that's really all we can do for example number 4, really. They're not the same factors, so we're not going to put it in one factor square. They're totally different. One is a plus, one is a minus. You're just going to leave it like this. Okay, let's move on to example number 4. Okay, always ask yourself, and I know I haven't been asking in the previous examples, but can we factor a GCF? Can we take out a, okay? In this case, we can probably take out a 3. Let's try that. Okay. Well, 75 divided by 3, 3/4 makes 75 cents. So it's going to be 25x squared over here. 363 divided by 3, it will be 121. Okay. And then don't forget the 3 that we took out and then extracted. Okay, let's see if this is different. It looks like it might be, but it's always good to check. Square root of 25x squared is going to be 5x. Square root of 121 is going to be 11. And there is a minus sign. And so your final answers are going to be 5x plus 11, 5x minus 11, with the 3 up front. Okay, I'm almost done with the examples, and then after that, you are going to do a you-do. Here is example number 6, last example. Okay, we got 2 variables, 81r squared minus 100p. Sorry, 81r squared minus 100p squared. Let's see if we can do differences of squares, and most likely we can. Okay, square root of 81r squared is going to equal to 9r. Square root of 100p squared is going to equal to 10p, and there's a minus sign. And so your final answer, 9r plus 10p, 9r minus 10p. And that is all we can do for that. You could also write it as if you switched it around. Like if you had the minus sign first, that's totally okay. 9r plus 10p. Yeah, it is the same. This is the same thing. Okay. Okay. Okay, so we are now in the you-do portion, and I want you guys to pause the video. There's going to be quick answers to follow if you just want to see the answers, and then afterwards, if there are some answers that you had incorrect, then I can provide some explanations along the way. Okay, so here are your you-do problems: 4x squared plus 36x plus 81. For number 2, 36x squared minus 60x plus 25. Number 3, negative 242x squared plus 44xy minus 2y squared. 4, 4x squared minus 49. And number 5, 400x squared minus 36. And this is number 6, 169x squared minus 441y squared. So definitely pause the video, grab a piece of paper, try to do them on your own. Quick answers are going to follow in about 10-15 seconds. I'm going to keep this rolling, and then I'll provide you guys with those answers and the explanations. Here are the quick answers. So for number 1, you should be getting this one. It's quantity 2x plus 9 squared. Number 2 is quantity 2x minus 5 quantity squared. And number 3, the only difference is this one has a 1, this one does not. They're the same thing anyway. So negative 2 quantity 11x minus 1y squared, or even in this format, is totally okay. All right. Well, those are the answers for numbers 1, 2, and 3. Here are the answers for 4, 5, and 6. 4, you can go 2x plus 7, 2x minus 7, or you can even have it so that the factors are switched. That's totally okay. Number 5, 4 parentheses 10x plus 3, 10x minus 3. And then number 6, quantity 13x plus 21y, and then quantity 13x minus 21y. Did I say minus over here? So plus, and then minus. Okay, so here are the quick answers to those, and then if you want to stay tuned to see the explanations, then you guys can. Okay, well, here are the explanations. I'm going to start off with number 1 first. We can't GCF anything, and so we are going to do this format over here. We're going to break up the 4x squared into 4x and x. There's also a possibility of 2x and 2x. 81, I already immediately think of 9 and 9. And then I think the pair that's going to work, the pairs that are going to work is the 2x with the 9, and the other 2x with the other 9. Okay, I'm just going to write the proof down over here, just so that we have some written proof that it works. This is going to be 18x plus 18x, and then yes, that's the 36x that we want anyway. Alright, now into the 2 factors. First pair that works goes on the outside. Okay, and then the second pair that works goes on the inside. It's a good thing that they are the same. So if you made a mistake, then it wouldn't have mattered, because they are the same factors, and because that they are, we're going to write them as a perfect square like this. Okay. Alright, number 2, there's no GCF whatsoever, and so we're going to have to do this method of breaking down the factors and guessing and checking. 36x squared, there were some possibilities. You could have gone 9x and 4x. There's also 6x and 6x as well. 25, 5 times 5 is 25, but because you want a negative 60, maybe not 2 positives, and possibly 2 negatives might be better. And that is the better pair to use, because that's going to give us the negative 60 that we want if we pair it up with the 6x. Okay, let's try it out. 6x times negative 5 plus 6x times negative 5, negative 30x plus negative 30x, and that is the negative 60x that we want. Okay, now into the 2 factors, 2 parentheses. Okay, alright, so then that's just going to be 6x minus 5 quantity squared on that one. Okay, alright, number 3, is there a GCF? And actually the answer is yes. Because there's a negative up front, we're going to divide, we're going to factor out a negative 2 and extract that from those 3 terms from the trinomial. And so when we go negative 242 divided by negative 2, that's going to give us a positive 121x squared. Okay, 44 divided by negative 2 is going to be negative 22xy, and then negative 2 divided by negative 2 is going to be positive 1y squared. Okay, And then afterwards, don't forget the -2 that we extracted. Okay, we can't do any more GCFs, and so we're gonna break these. Okay, 121x squared. I'm already thinking 11x times 11x, and I'm just gonna list that one down. The 1y squared, I think of 1y times 1y, but again, because you want a -22, maybe not two positives, maybe two negatives is a little bit better, and it is. Okay, the 11x will go with a -1 because that's -11, and this other 11x will go with the other -1 because that's going to be the other -11. Okay. First pair that works goes on the outside. Second pair that works goes on the inside. Again, luckily that they are the same thing. Okay. Don't forget the -2 that we have over here. Alright, and because they are the same thing, you can write 11x minus y quantity squared, and you don't have to put that 1 anymore. If you didn't, I don't think it will make a difference anyway. Okay. So that's going to be that explanation for number 3. Okay, so I'm going to move on to number 4. Okay, number 4, there's no middle term, but is this a difference of squares? The answer is yes. If we do a square root of 4x squared, it's going to be 2x. Square root of 49 is going to be 7, and there is a minus sign. And so our final answer is going to be 2x plus 7, and then 2x minus 7. Factor switched, it does not matter. Okay. All right. Can we take out a GCF? Is there a GCF? The answer is yes, and more than likely we can take out a 4. Then that way what's going to happen is 400 divided by 4 is going to be 100x squared minus 9. Okay, and then we can square root these. 100x squared is going to be 10x. Square root of 9 is equal to 3, and there's a minus sign, and so your final answer is going to be 4, 10x plus 3, and then the other one's going to be 10x minus 3. Okay, all right. Last one. I don't think we can do a GCF, but if you are having trouble with the square roots, you guys can use the calculator to help you out a little bit. Square root of 169x squared is going to be 13x. For the 441y squared, it's going to be 21y. Okay, and then you're just going to put them in that format: 13x plus 21y, and then 13x minus 21y, and then that's really all we can do in that case. Okay, phase 8 is done. Thank you so much for watching, and I am planning to do a little bit more phases pretty soon, group factoring, and then all the higher forms of the quadratic expressions, equations. So stay tuned for those phases. Okay, thanks you guys.